All right, the next set of algebra vocabulary we are going to look at are properties of real numbers. These are things that we use all the time. You've been using them since you learned how to add and subtract and multiply and divide, but we're going to put some academic vocabulary to these. We're going to be talking about the associative property, the commutative property, the identity properties, and then we're going to kind of dive a little deeper into the distributive property throughout this lesson. So I'm going to go ahead and zoom in on these little nuggets. So properties of real numbers help us to simplify math expressions and help us to better understand concepts of algebra. You've been using them for years. All right, let's take a peek at the first one. We have the associative property of addition and multiplication. So what's important to note is that this property will only work if our entire problem is all just addition, or our entire problem is just multiplication. Let's look at how it works. What you'll notice here is that our associative property deals with parentheses. So the first thing I want you to do around this is draw some parentheses. Our associative property must have parentheses in it to be, well, the associative property. What it says is that if my problem is all addition, I can move my parentheses and still get the same answer. It's a little hard to see that with letters and variables, so let's take a peek at it over here where we have numbers filled in. Since my problem is all addition, instead of doing 4 plus 9 first, because it's in parentheses, I can move my parentheses to make my problem a little easier to solve. And this is something you guys do all the time without even realizing it. Because 9 plus 11, it's a lot easier to chunk, right? 9 plus 11 gives us 20, and then boom, we could add that 4 for 24, right? If we kept the parentheses over here, we're still going to get the exact same answer, but it might be a little bit more cumbersome, a little bit more work to solve. 4 plus 9 is 13, and then 13 plus 11 is 24, but wouldn't you guys agree that doing 20 plus 4 is just a lot easier than doing 13 plus 11? Right? It's just a little easier. Same thing happens down here with the associative property of multiplication. Again, it has to have parentheses to be considered the associative property, and it only works if my entire problem is all multiplication. Again, saying that I can move my parentheses and my answer is still going to be the same. And again, the purpose of it is to make our problem a little easier to solve. For example, what do you think you're going to be able to maybe even just do completely in your head? 9 times 4, which is 36, and then 36 times 5. Or would it be easier to do 4 times 5, 20, and then 20 times 9? Well, that's pretty easy, right? 9 times 2 is 18. Add that 0, and we get 180. We would still get 180 over here too, but this side over here was just friendlier numbers to work with. All right, so again, associative property of addition and multiplication must have parentheses. It means that I can move my parentheses in my problem and still end up with the same answer. All right, our next one, the commutative property. Again, it only works if my entire problem is addition, my entire problem is multiplication. It sounds fancy, but really it's super basic. Our commutative property is all about changing the order. A plus B means the same thing as B plus A. Would you guys agree that 3 plus 7 is the same thing as 7 plus 3, right? The only thing that changes is the order of things. And so I'm going to jot that down over here. The order is what changes. I'm still going to get the same answer. Same thing with multiplication. C times D is D times C. Well, you guys, hello. 8 times 5, that's the same thing as 5 times 8. I'm going to get the same answer. Again, properties that you've been using, but now we're just adding some academic vocabulary for you to be able to explain it. Okay, then the next thing we have are our identity properties. We'll talk about the additive inverse in depth a little later throughout this unit, but we'll kind of go over them while we're here. All right, the identity properties, though, is what I want us to focus on first. All right, so I want you to think about this. Picture yourself brushing your teeth in your bathroom mirror in the morning, and you blink. Are you suddenly someone else? Are you like did you suddenly turn into your best friend? Did you suddenly turn into a cartoon? No, right? It's you. It's you. So our additive identity, additive meaning addition, what can we add to a number and not change its identity? What can we add to a number and not change its identity? Well, 0, right? We can add 0 to any number. We could add it to a fraction. We could add it to a decimal. We could add it to a negative. And we would still end up with the exact same number. Okay? Same thing happens for the multiplicative identity. Say that out loud. Multiplicative. 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 The multiplicative identity deals with multiplication. What can we multiply any number by and not change its identity? Not change that number. Multiply by 1. Right? 18 times 1 is still 1. Negative 1 million times 1 is still negative 1 million. 1/2 times 1 is still 1/2. Okay, so multiplicative identity is what can we add or what can we multiply a number by and not change it. All right, then we have the additive inverse. The additive inverse is essentially telling us that we can add a number's opposite and we're going to get 0, right? If I take a positive 4 and I add its opposite, what's the opposite of positive 4? Negative 4. If we take a number and we add its opposite, we are going to get 0, right? We've seen that before over and over and over again. Our multiplicative inverse is a little bit more complicated. It's telling us that we can take a number and multiply, of course, because it's multiplicative, by its inverse, and we are going to get 1. Right? So I'm going to expand this out over here. So if I take 5 times its inverse, we have to think about what we did when we multiplied fractions. That means we have to make 5 wholes into a fraction, which is 5/1. And multiplying by the inverse is taking this fraction and flipping it upside down. Okay? When we multiply across, then we end up with 5/5. And 5 out of 5 is equal to 1 whole. Okay? We can do that even with a fraction, right? If we had 2/3, if we're going to multiply by the inverse, we're going to take that fraction and flip it upside down. Multiply across, we get 6/6. And you guys, 6/6 is equal to 1 whole. All right, we're going to dive into the distributive property on the next page. I'm going to skip it for now, and we're going to look at our the way that I've remembered these, because oh my goodness, when I was y'all's age, I had such a hard time remembering these. So here's what I used to say to myself. It sounds really silly, and this is why we have Boss Baby here. I know my ABCs. Associative before commutative, because it's alphabetical. Associative before commutative, and the two things that the associative and the commutative property deal with are grouping symbols and ordering. So associative before commutative, grouping before ordering. Boom. All right, so just a little nugget to help you remember which is which, because it can get a little confusing. Associative before commutative, grouping before ordering, meaning the associative must have grouping symbols, and the commutative property changes the order of our numbers. All right, there we go, guys.